Hello everybody. In this video we are going to go over 2019 free response question number 3. This will be a no calculator problem. So let's have a look at this problem. Number 3. The function f, the continuous function f is defined on a closed interval from -6 to 5. The figure above shows a portion, so it's only from -2 to 5. So has two lines and a quarter of a circle, center at 5, 3. So that's a quarter of a circle. So it is known that the point 3 minus radical 5 is here. So most likely when we have a circle, piece of circle on the graph, and the equation of a circle is not given. So in your mind, you should know probably we are going to use the area to calculate the integral. So part A, given -6 to 5 equals fx dx equals 7, find the value from -6 to -2 fx dx. So based on the property of integral, -6 to 5 fx dx will be equal to -6 to -2 fx dx plus -2 to 5 fx dx. So this is what we are looking for. So integration -6 to -2 fx dx will be equal to -6 to 5 minus dx. And this is 7. That's what's given. So now let's have a look from -2 to 5. How do we calculate the integration here? So from -2 to 5, from here to here. As we realize, we have to use the area to calculate the integration because none of the functions given. So A1 and A2, they are the same area but opposite sign, so it's cancelled. A3 and A4, opposite sign, same value, cancelled. So whatever left is the trapezoid here. Trapezoid 1 plus 3 times height 1 divided by 2. That's the area there. Using the quarter of a circle to get the area here, this is what we need. So the area there will be the area of the square, which is 3 times 3 minus the area of the quarter of the circle, which is pi times r squared over 4. So this gives us 7 minus 4, 2 plus 9 minus 9 pi over 4. 7 minus 11, so it's -4 plus 9 pi over 4. Evaluate the integration from 3 to 5 to f prime plus 4 dx. So based on the property of integration, we can split this into two parts. 4 dx. And these two can be moved out. Integration. Let me write down one more step. So f prime dx, when we take the antiderivative, this will give us f5 minus f3 plus 4 times 5 minus 3. So f of 5, if you look at f of 5, when x equals 5, y equals 0. We can look at here too. And when x equals 3, as we know what's given, the y value is 3 minus radical 5 plus 8. Our final answer, 2 plus 2 radical 5. Let's have a look at part C and part D. Part C, the function g is given by integration from -2 to x f of t dt. Find the absolute max of g on the interval from -2 to 5 and justify your answer. So we need to take the derivative. G prime equals what? So because g integration here, so when we take the derivative of an integral, we have to use the second FTC. So g prime here will be equal f of x. So you have to be careful in this case because this is x and that's a constant number. When we take the derivative, we don't have to use chain rule or anything. For example, if g of x equals integration -2 to the x squared, when we take the derivative, g prime will be equal to f x squared times 2x. See the difference? You have to use chain rule here. Here and 1 point here. So x equals -1 and 1/2. So those are the two critical points we have. So in order to make sure it's a maximum value and it's closed interval, we are going to make a table here. So this is the x value, and that's g of x. So when x equals, the boundaries are -2 and 5. Our critical point, -1 and 1/2. So when x equals -2, g equals -2 to -2, fx dx, which is 0. When x equals -1, -2 to -1, f dx. If we look at the graph, it's the area here. It's 1/2 times 1 times 1 equals 1/2. And when x equals equals 1/2, our integration is here. So these two, a1, a2 are canceled. So that will be the area there. -1/2 times 1/2 times 1 give us -1/4. And last, -2 to 5, f dx. We already evaluated before, which is 11 minus 9 pi over 4. So if we look at these four numbers, 0, 1/2, -1/4, and this 11 minus 9 pi over 4, the maximum value is this one. So at x equals 5 is our maximum. D, we are looking for the limit x approaches 1. When we solve for limit, the first step is always plug it in. So when we plug it in, 10 to the first minus 3 f derivative at 1 over f of 1 minus arctangent of 1. So you have to check, make sure it's not 0 over 0. If it's 0 over 0, we can use the L'Hopital's rule. So 10 to the first is 10. 3 times f1 prime. So f1 prime means the derivative of f at 1. It's the same thing as the slope at 1. The slope at 1 here, the slope of the line, m equals rise over run. So 2, 1, 2, 3, 4. 4 over 2 equals 2. The slope equals 2. Divided by f of 1. f of 1 here give us f of 1 equals 1. Arctangent of 1. Tangent of what give us 1 pi over 4. This is our final answer here. So let me put all the solution together and let's have a look how do they grade it. So I look at the rubrics. So part A, this part, how do you use the property? 1 point. The area, 1 point. and final answer, 1 point. The second part, the fundamental theorem calculus, this is 1 point, 1 point. Part C, second fundamental theorem calculus, 1 point, and the explanation here, 1 point. Final answer, 1 point. And the last problem, 1 point. So altogether, 9 points.